Correctly or not, microservices has become the de facto way to build apps today. However, the idea of microservices is really a tough thing to put a clear beginning to. A commonly pointed to birth of the architectural pattern starts around 2011 with James Lewis. James, consultant at ThoughtWorks at the time, was interested in something he called micro apps. It was a pattern that was becoming increasingly used at places like Netflix. You can actually find a talk from Adrian Cockcroft at QCon SF in 2010 where he talked about cloud services at Netflix on InfoQ. In 2012, several of these players gathered at a conference and debated this architecture. At that conference, the term microservices became an architectural pattern with a name. Today on the podcast, we're talking to one of the people, one of the thought leaders who was at that conference, and through his consulting, his books, his talks, and his passion, has helped to shape what we think of microservice architectures today. Today, we're talking to Sam Newman. Sam is a consultant in the cloud CI/CD space, perhaps most well known for his thought leadership around microservices. The big focus on this podcast is really to chat about his new book, Monolith to Microservices, Evolutionary Patterns to Transform Your Monolith. That story from James Lewis, in part, is taken from that book. So today on the podcast, we're going to be talking about understanding the problem that you're really trying to solve when it comes to microservices before you make that choice. We're going to talk about technical and organizational challenges around microservices and Sam's thoughts on how to address them. We'll spend some time discussing decomposing the database and some of the patterns to think about when you're dealing with that monolithic database. And then once you're on that path, we'll talk about some of Sam's thoughts on how to deal with the growing pains that inevitably come from microservices. So today on today's podcast, expect to hear stories, advice, patterns and anti-patterns, and some best practices on microservices from Sam Newman. As always, thank you so much for joining us on the InfoQ Podcast. Sam, welcome back to the podcast.
Thanks so much for having me back again.
So late last year, November timeframe, you published a new book, Monolith to Microservices, Evolutionary Patterns to Transform Your Monolith. So what have you been doing with all the copious amounts of free time since then?
Writing a second book. I'm actually...
a third book, right?
Yeah, a third book, really. Yeah. So the reason I wrote that book was I started doing a second edition of my first book, Building Microservices. And the chapter in Building Microservices, I think chapter 5, was where I looked at how you break systems apart. And I started rewriting the second edition of my book by looking at that chapter. That chapter went from being 5,000 words to being 40,000 words in about a month. And I thought, okay, this needs to be its own book. So I kind of split it off really as its own book. So you can read it by itself, but it also does work as a companion. It's like a deeper dive on those topics. And so since I wrote that book, I've been dealing with the current situation, being locked down in my home. So that's, as an independent consultant, getting your customers happy with doing things online. It's actually been easier than I thought. People are much more open to doing online consulting now than they were in the past, whereas because they wanted to see you in front of them. Literally, it was just about half an hour ago, I was working on some stuff around the second edition of Building Microservices and actually doing a lot of exploration of computer science papers written in the early 1970s. I was descended down that particular rabbit hole this morning.
Yeah, it's definitely an interesting time now. I can't say it's exactly working remotely, the culture we're in now, but it definitely is an interesting time, to say the least.
To be sure.
So one of the questions that I always have when I'm talking to someone who writes books and consults is, what does your writing process look like? I'm curious.
Well, I've spoken to lots of authors and they're all different. So as in how it works for them, it's all quite personal. I think I'm what I consider to be a bit of a momentum writer. So when I'm writing, say, an initial draft of a chapter, I have to have the structure, at least a rough structure already mapped out. And that's the kind of thing that will bounce around in my head for like months beforehand. I'll sketch that out. And then literally I'd like to sit down and over a period of, say, 4 or 5 days, just brain dump. And for that to be most effective, I really need to write blocks at a time. So I need to have like 3 or 4 days in a row to really get up speed on that. And that then helps me get out that first initial draft. Then I kind of review a few times. So for me, I can get my stream of consciousness down as prose fairly effectively, but I'm not somebody that could write that initial bit of work an hour here, half an hour there. So that means really from a work life point of view, a work book balance, I kind of have days where I'm writing and I put nothing else in that day apart from writing. If I've got calls, if I'm doing some online training, I'll mix those days with other sort of administration type things I've got going on or things I need to get around the house. But I try and keep writing days as writing days. I can't write for more than about 5 or 6 hours a day, rare exceptions. So today was a writing day. I finished at 3:30. After that, anything else I get done is all gravy. Once I've written that, and I'm getting review feedback from people, At that stage, I can go through and process that review feedback in little chunks here and there around other bits of work.
For me, when I'm writing, I find like I have to write code and then shape the text for the code. Do you find code first or write first and then shape the code to what you wrote?
It's sort of interesting because I think most of mine actually start as a story. So I think most of the things I write start off life as a presentation or a workshop. And on those things, I'm taking somebody on a journey and then I'm writing that journey down. The books I write, I don't write code-centric books because there are other people that do that really, really well. And I want to make my books sort of more broadly applicable to people. Right? So I don't want to alienate the .netters because I'm talking about Java or whatever, right? So for me, it's more that if I want to share these ideas, how would I do that if I was chatting to somebody in front of me? And I'm actually quite fortunate that I do training actually as part of how I make my living. So I actually get to go and take those messages out and take those stories out and almost road test them by actually delivering training. And then after iterating on that a while and getting the sort of the flow, the beginning, the middle, and the end of each of the topics kind of right in that forum, I then almost write that down. And that's the process that's worked most for me. And I think I do sort of try and think in terms of that narrative arc. And that tends to be the way I work more than just throwing in lots of topics I want to fit in. It's more that I'll do that narrative arc, then I'll come back and say, I've missed some stuff. How do I sort of shoehorn it back in again?
And then you have a second and third book.
Well, yeah. I've got lots of ideas about books that I want to write after this one is done, but got to focus on what's in front of you.
So speaking of that, let's dive in and start talking about monolith to microservices. So tell me about this book. You already mentioned kind of briefly the origin, but tell me more. Tell me about why this book and why now.
The vast majority of the people I speak to that come to my workshops, I ask this question often, who here has got a system that's too big, like when I do a conference talk and everyone puts their hands up, right? The vast majority of people don't start with a blank sheet of paper. They start with an existing system and they think, oh, microservices are attractive. Well, how do you make those two things work? Do you ditch the entire system and rebuild something from scratch? I think that's extremely problematic in most situations. So the reality for the vast majority of people is that if they're interested in a microservice architecture, then they're going to have to find some way to take what they've already got and migrate it towards a microservice architecture. And even if you start microservices first, you get to situations where you find further decomposition is needed. And so I really wanted to go a bit deeper into that area to give people some concrete tips and advice about how they could make that journey happen for themselves. And as part of that, sort of looking at the people process side of things, then looking at sort of how the code, so how you pull the code apart and different patterns around that, and then spending a lot of time around the data. And then the idea being that I can sort of share some concrete patterns, and I've got more case studies in the book than I had in building microservices, and to show what is possible. And I actually think it's healthier for people, in fact, to sort of take that migratory approach in an iterative fashion. I think it's a much more sensible approach than trying to build a microservice architecture from scratch. Even if you're rebuilding an entire system from scratch that you already know, I still actually think migrating the existing monolithic architecture, or whatever you want to call your current system, is a much healthier approach.
Back in March at QCon London, I was doing the Architecture You've Always Wondered About track. Ian Thomas from the STARS group was in that track, and he kind of started the talk off by referring back to your talk from the previous day. So Ian was part of a project that took kind of the sports book for Poker Stars and the sports book for Skybet and merge those things together. So you had kind of a greenfield app that they were building from these two things. And in your talk, you talked about, look, microservices isn't the point you start. It might be what the architecture you get to, but really at starting at that MVP, you're starting at the simplest thing that works. He put up this picture, I remember, and everyone cracked up because he showed this picture of you kind of looking straight at the camera. And he said, I felt like when you were saying that don't start with microservices, you were looking directly at him. One of the things that people that first come to one of your talks, I think that they're initially surprised off, you're not ringing the bell that microservices is the jumping off point. Can you talk a bit more about that?
Yeah, I don't think that anybody that's spent a lot of time looking seriously at the challenges associated with building a microservice architecture thinks that they should be right in all situations. I mean, fundamentally, a microservice architecture is a distributed system, and distributed systems are complicated. They have baggage associated with them. And so there's a lot of complexity that comes from these kinds of systems. The idea that everybody is aware of those issues and knows how to deal with those problems, it just isn't true. We may have learned about some of those ideas at university, perhaps, but they're not things that most people have to deal with. And so for me, it's like, well, okay, microservices has all these problems, and yeah, it looks cool, but it's also these these problems as well. And so for me, when I'm working with a client, my mindset typically is not why shouldn't we use microservices? It's normally why should we? And, I think I got asked, what's the one thing you'd say when you would use microservices? And the answer normally is when we've tried everything else. Because for an awful lot of things that people want to do, there are often easier ways to achieve the same goal. So a lot of people want to improve the scale of their application. Have you tried having multiple copies of your monolith, right? Have you tried getting a bigger machine? There are often the quicker things that you can explore and experiment with beforehand. Even then, a lot of this comes down to is even if you do want to do microservices, it's the extent to which you do them. So the analogy I've always tried to use with adopting microservices is say it's not like flicking a switch. It's not off or an on state. It's much more like a dial. And so if you're interested in trying microservices out, well, then just create one service. Create one service, integrate it with your existing monolithic system. And that's like turning the dial a little bit. Just going to try one, see how one works. Because the vast amount of the problems associated with microservice architecture are not really evident until you're in production. And so it's super important that even if you think microservices are right for you, that you don't jump all in. You dip your toe in the water first and see how that goes before you kind of turn that dial up.
One of the things that I liked in the book, and I've fallen in this trap before, of just kind of thinking of monolith as this one kind of nebulous, just one kind of classification of an app. But you kind of break it down and you talk about different types of monolith, and that even these different types of monolith can move you towards this journey towards microservices. Can you talk a bit about that?
Yeah, so I talk primarily about a monolith as being a unit of deployment. And I say, that could be all of my codes in one process. It could also be a distributed monolith where I've got a distributed system that I'm all deploying together. But one of those sort of monolithic patterns that can often work good as a migratory step would be what we now call the modular monolith, where you've got all of your code is packaged together in a single process, but that code is actually compartmentalized into separate modules. And this is a cutting edge idea from the late 1960s that we've just realized existed, right? So, if you look at all the work behind structured programming, information hiding, it's all how do we organize code into these modules that can be worked on independently. And actually, for a lot of people, if you have, say, all of your code running on a single process, you sidestep a lot of the challenges of distributed systems. If that code is organized around modules, and if you've got your module boundaries right, then that also is potential migratory path. You could say, well, my first microservice, I'm going to take one of those module boundaries and potentially use that now as a service. So there are sort of different ways you can kind of make that journey happen.
Yeah, absolutely. Without necessarily having to deal with the network partition in the whole process.
Absolutely.
So another part of the book that I really enjoyed was about organizational challenges. There was a phrase you used about taking people on a journey. When you say take people on a journey when it comes to microservices, what did you mean?
It can happen at a lot of different levels. One of the common questions I get is, how do I convince my boss that we should do microservices? That's one of the ones I get a lot. This often comes from developers. And it's like, and I always say, well, why should they care? What's in it for them? So, there's that side of it, which is some of what you're going to do. Implementing a microservice architecture or moving to a microservice architecture won't be cheap and it won't be quick. So if you are going to take your boss on a journey towards that microservice outcome, you've really got to explain why you're doing it. And I talk in the book about separating activity from outcome, right? So, implementing microservices is an activity. The outcome shouldn't be microservices. You don't win by doing microservices. The only person that wins if you do microservices is me, because I sell books about microservices, right? You're implementing microservices to achieve something. What is it you're actually trying to achieve? And it's amazing how many people I chat to who can't give me a clear articulation of why they're doing microservices. So it starts about having a real clear vision for what it is you're trying to achieve. And then you can say, is microservices the right approach for this? And are we using microservices in the right way?
Decompose that a bit. So what are the smells? Like you're running a monolith and you start to have a set of problems. What are some of those smells? What are some of those problems that kind of indicate maybe microservices is something you want to look at?
I would say the most common one that I see for larger enterprise organizations is that they want to have lots of developers working on a given problem, and those developers are getting in each other's way. So what they want is they want those developers to be able to work more independently from each other, kind of reduce what I call as delivery contention. So how do I have different autonomous teams working more in isolation, but still have the things that they create come together to create an overall system? So that's a big part. How do I get more people working more effectively and efficiently? Scaling comes up sometimes, but much less frequently than you think. But there are some aspects around scaling that can be really beneficial with microservice architectures. Data partitioning is something I'm seeing a lot more. If you isolate, for example, where your personally identifiable information is, you can sidestep GDPR concerns. In some, you can say, well, this part of my system has to have PCI sign off or GDPR sign off, but this part of my system doesn't. And so those are sort of just three quick examples of types of problems which can often lend themselves quite well to microservice architecture.
Okay, so you start to get these smells of team velocity, and you start to see some areas where like privacy concerns or scaling different parts of your system may be different. There was famously a blog post years ago. Martin Thompson had "You must be this tall for microservices." Before you can really jump off that cliff and even kind of incrementally decompose your monolith into microservices, what are some of the things that you really need to make sure you have right?
Because I see that process of dipping your toe in the water as being something which is so gradual and it is a very gentle first step, I don't have a big shopping list of things that I say that people have to do. And some people say, oh, you've got to do X and Y and Z. It's like, you know what? Actually, you probably should have automated deployment of your system. But if you don't, and you're only adding one more thing to deploy, it's not the end of the world. There's sort of one big prerequisite that I always say people should do first, and that's actually to implement some form of log aggregation. And so by log aggregation, I mean some means by which a process can log files locally, and those files can automatically be aggregated in a central location where they can be queried and stuff. So traditionally, you think of things like the ELK stack. I really like Humio for this, but it's like that's the one prerequisite I really say, and I'm quite firm on. And the reasons for that are actually quite straightforward. The first is it's really useful, and it's the kind of thing that is going to help you a lot early on. The second thing is it's often a good test of an organization. If you as an organization and the different parts of your organization can't work out how to choose a tool and implement that tool effectively, and a log aggregation stack is a very simple thing in the grand scheme of things. If that's something that you can't do as an organization, the chances are that all the other problems that you're going to have to face in microservice architectures, they're going to be much tougher for you and probably not some things you're ready for. So I almost use it as a test of the organization, because rolling out log aggregation means you've got to find a tool, pick the tool, get the operations team on board, get it bought, get it installed, get it configured with your existing applications. It's not massive amounts of work theoretically, but if it is for you, you might be thinking maybe we should sidestep this whole microservices thing for a little bit.
Yeah, absolutely. I want to definitely come back and hit on logs, particularly with microservices as you start to scale them out and those logs and metrics start to become more voluminous. Before we get there, though, I want to talk about organizational culture and the impact that has on your architecture. So, Conway's Law talks about how your app kind of models the communication structures. So, you've got this monolithic application that probably presumes you have an organization that kind of models that. I guess as you start moving towards microservices, how does the organization need to change its shape to be able to support that architecture?
It's sort of interesting because I find that these things are often talked about in isolation from each other. Ideally, you get the most benefit when your organization and your architecture are aligned. And I talk about ownership models. I've got a talk called Rip It Up and Start Again, where I look at the different types of ownership models. In the ownership model I find most effective for a microservice architecture is a service is owned by exactly one team. One team might own more than one service. That keeps your ownership lines nice and clear. And this really is what you would think of as traditionally as being a strong ownership model, right? And that's the model I've seen that's works most effectively, and virtually every sort of large-scale microservices organization I've looked at, they adopt that sort of model. So my starting point is often, what is the existing organization? Because often the organization is already aligned around business concepts. That's the more modern shift that's been happening, away from sort of siloed IT teams to organizational structures which are more aligned around the nature of the product and around maybe product verticals. And that actually, if you're in that world already, your life becomes much easier. And then you'd be looking to sort of create services that sit cleanly within those organizational lines. I think it becomes much more problematic where you've got, say, things like sort of the classic three-tiered architecture types approaches, where you still have the database team, the services team, the front-end team, who just deal with tickets and they roll over on every single different part of the system. In that world and in that environment, it becomes very difficult to bring microservices in, because microservices are fundamentally a vertical slice, and hopefully a vertical slice through presentation, business, and data tiers. So that becomes more difficult. In those sorts of environments, it's much more like saying, well, this is what a microservice is. We need to get a team that is working in a more polyskilled fashion to own this stuff. And you don't do the whole organization, right? You convince people in the model and then you pick one team and see how that model works. I think what I've been quite unhappy with since I wrote Building Microservices is the fact that although I always felt that this was evident from what I was saying, so many people stop that kind of end-to-end slice of functionality at the UI tier. They don't include the UI. And I go to organization after organization where they still talk about front end and back end developers. And I have no problem with you being a front end specialist or a back end specialist. And I think calling yourself a full stack developer is kind of daft because as Charity Majors says, you're not a full stack developer unless you design the chips. I think being polyskilled, I think having polyskilled teams makes sense to me, right? But so many organizations have kept their UI as a silo. And that's been really disheartening. And I think part of this is maybe because we didn't talk about it enough early on and didn't highlight these challenges enough. But I think it's also partly been around the prevalence of single page app technology, which does cause issues around UI decomposition.
So what are your thoughts on the term micro front end? Is that just another name for microservices, or is it a complementary technology?
Micro front ends is very specifically the concept whereby you take a single page app and make it not a single page app anymore, right? I mean, it's talked about in the context of very narrowly single page apps. So the micro front end being, I don't have one single page app representing my user interface. I now potentially have multiple single page apps. We could then debate the word single at this point. So I can coexist them inside the same browser pane. So this is really about how do you take single page app frameworks and work with them in such a way that you can now break that work apart into different applications which can be worked on and deployed independently. So you're now dealing with issues like, well, how do you sandbox your whole NPM chain and all this sort of stuff? So it's absolutely, I think, would be a supporting technology for me. Like the use of micro front ends would be how I would decompose my user interface if I was trying to do that with single page apps. If I've got a website, I could use pages as my unit of decomposition. I don't even need to think about micro front end. I'm just serving up different pages from different services. So it's definitely a sort of a supporting piece of technology and also a supporting concept.
Absolutely. Okay. So one of the things that you talked about in the book was a release train being a kind of point in time in a journey towards like CI/CD, but not necessarily the destination itself. Can you talk a bit about that?
I used to do a lot of CI and CD work, and I still do. Just to be very quick, a release train is the idea that you set a sort of cadence. So you say every 4 weeks the release train leaves, and all functionality that's ready goes out on the release train. That's the idea, and it's a really effective technique to help people get used to delivering software on a regular cadence. And the idea then is that you increase how frequently the release train leaves, and then eventually you get rid of the release train and move towards delivering on demand. So I kind of always described a release train as a useful set of training wheels on your bike, but you want to learn how to cycle properly. And so eventually you get rid of them. I talk about them in the context of the book because I see some organizations adopt a release train for a services-based system, and that can sort of codify the idea that lots of services get released together. And so I talk about in those situations, if you've got like 20 different services, each individual service should have its own release train. You don't want a release train for the whole system. Sarah Wells has talked about this as well, I think, where she's seen this happen, where org teams which have we release every 4 weeks, you end up with a distributed monolith as a result. And so I've sort of said, well, actually, okay, great. If you've got a release train, that's fine, but understand why you've got it. You want to move beyond it. So if you've got one for, say, all of your teams, allow each team to have their own release train. That's a good first step. Then start to increase the cadence of those releases and eventually move to release on demand. And that's just what's in the continuous delivery book. This isn't cutting edge information, really. I didn't feel I had to have this conversation, but with something like Safe, for example, which effectively codifies the release train as being the way to release software, it does come up more now. And I think it just needs to be talked about a bit more to explain this isn't an aspirational technique. This is something which for many people is a stage you move through towards proper release on demand or release when ready type continuous delivery flow.
Yeah, absolutely. It made a lot of sense when you made the relationship that if you can't move beyond it, that you may be building distributed monoliths and reinforcing the patterns of a distributed monolith. Made a lot of sense to me. One of the big aspects of this book, as you're reading through there, were a lot of patterns. So you'll see familiar patterns in there, like the strangler pattern, to be able to kind of break off units of a monolith and be able to kind of strangle it down and kind of move it out to a microservice. There's other patterns in there. There's branch by abstraction, parallel runs, decorating collaborators. What are some of the other patterns in the book that might give an architect kind of the same mileage that they got out of the strangler pattern?
I think branch by abstraction is a big one. I think it's overlooked because I think the branch by abstraction pattern is typically only talked about in the context of trunk-based development. And some people find trunk-based development controversial. We won't have that argument again because people who think trunk-based development is right are also correct. So because of that, that pattern is only looked at in the context of trunk-based development. And so people don't even look at it unless they're doing trunk-based development. I should probably explain it, shouldn't I?
I was just about to ask that. So here, I'll set it up for you. What is branch by abstraction?
You could distill it down to its smallest form and say that this is true list cost substitution principle at one level. But the idea behind branch by abstraction is that you want to re-implement a piece of functionality, potentially to change that functionality, or in the context of microservice architecture, to migrate that functionality to be a new service. And so what you're doing is basically you've got the existing code and you don't want to break the existing code, but you need to come up with a new version of that code. Now, I could do that in source code branching, or I could do that in the same code base. How do I do that? With a branch by abstraction. So effectively, I create an abstraction point that allows me to say toggle between one or the other implementation. So as a really straightforward like code level way I might do that, I might have an order processor class that wants to send updates when the order is being dispatched, right? So in an object-oriented system, I would inject a notifications interface. That notifications interface could have more than one implementation. So if I use that, I could have my notifications implementation, which actually does all the functionality inside my monolith. I could have a microservice notification implementation that actually calls out to a separate notification service. At runtime, I could then change which one of those implementations I'm using. Could be done on the feature flag or something else. So at one level, this is just abstractions and toggleable abstractions. When we do it in the context of a microservice migration, what we're typically looking for is to be a refactoring. Like a refactoring is something that changes the code without the structure. When you're migrating functionality from an existing application to a microservice application, we typically want to keep the functionality exactly the same so that we can compare and make sure we've done it well. So this is effectively we're creating two different implementations of the same abstraction with exactly the same behavior, which is really Liskov substitution principle. Although often when you do branch by abstraction, you're varying the behavior. We typically don't want to do that in a microservice migration, because if we can run both those implementations, we can make sure they're working in the same way, we can compare results, and so on and so forth.
So let's keep going to kind of like that natural extension of this. So if you follow along and you do branch by abstraction and you have the ability to inject, made you feature flag it, do you release that as like a canary and then instrument it to compare the results? What's the follow on once you've done that to know whether this is really the right approach?
A lot of it does depend a bit on a feature by feature basis. I mean, it's down to the risk of this change you're making, everything else. If you can start at like the extreme comparison, probably the ultra cautious end of this would be to do a parallel run. So a parallel run would be where you would run all calls through both implementations of that piece of functionality, compare the results, and then say, yes, it's working. So typically in that situation, you'd have like the old implementation, which is the one you trust, your new microservices one, which you don't yet trust. Whenever a call comes in to use that abstraction, you pass that call on to both implementations of that abstraction. And so then you're getting a complete like by like comparison. That comparison can be done live, that comparison can be done offline. And then when you get to a place where you're confident, you can say, okay, well, I can now go on with the new version because I know it's working appropriately and I can remove the old version. The thing with a parallel run is you're getting to compare the results. If the microservice implementation misbehaves, that functionality has never actually been made visible to the customer, right? Because the results of the implementation you service to the customer are from the old implementation, right? So if I'm calling the monolith calculation and I'm calling the microservice calculation, I want the answer to be the same, but I'm never going to surface any answer to the customer other than the one that comes from the monolith implementation until I'm at a point where I trust it. And that means that any problems with your microservice execution are completely hidden from the customer. A canary is a different track on that, of course, would have a certain portion of the traffic go to the microservice implementation. And so that means if that had a problem, then those people who are in that canary group would see that issue. Now, if your canary group is actually your internal customers or your internal beta test team, that might be acceptable. So a lot of it will depend on the business context. I sort of talk about parallel runs. And so branch by abstraction as a pattern makes it quite easy to implement parallel runs. It also makes it quite easy to implement sort of internal canaries. And I sort of talk about those things as being under the umbrella of what we call progressive delivery. So the different techniques around how you roll out functionality to end users.
Yeah, totally makes sense. So what happens when you have a monolith and there is, I don't know, COTS functionality that is embedded within the monolith? I don't know, CRM or CMS or something along those lines. How do you deal with that COTS? Do you wrap it? What are some of the strategies there?
So wrapping it can work. Wrapping it is a good technique. I think, I can't remember if it's in this book or on building microservices, I talk about our experiences of helping move away from a Salesforce-based system. There's a Salesforce-based application dealt with accounts and revenue and project information and everything else. And what we started doing was wrapping it with multiple services. So I stopped people going straight to the Salesforce for the account information. And I said, you're going to the account service. Behind the scenes, the account service was really just shelling out to talk to Salesforce. So initially, we were really just providing almost like an adapter layer on top. But that then got you from, rather than going direct to the COTS system, it then led, we can then look at the migration behind the scenes. And that approach can work fairly effectively. And at that point, you can start doing things like strangler figs inside those adapters to bypass functionality around. Another option is just good old fashioned get hold of the database, right? I mean, some of the COTS products don't have nice APIs. Salesforce actually has a pretty easy to use relatively speaking, it's a pretty easy to use API, right? So we've got a lot of things we can do at that layer. But some software doesn't have that. Sometimes all you've got is the database that all this data is stored in. And in those situations, this becomes more problematic. So there you might have to do some sort of kind of weird change data capture things to extract the data out. What I tend to see with COTS-based migrations of functionality, because you don't have the ability to change the monolith themselves in that case, because the monolith is the COTS products, you can't use patterns like branch by abstraction because they require an internal change to the structure of the code. Instead, you're much more limited in the options. That can often result in you having to take maybe bigger slices of functionality out of that system. A COTS product with a decent API gives you a lot more options about how to do that. But if you've got maybe a graphical based kind of very much black box type COTS product, sometimes your best bet is to go into the database or to sort of take bigger slices of functionality out of that system.
Speaking of the database, there's quite a bit in this book that talks about kind of decomposing the database. I know the answer, but why so much attention in the book for decomposing the database?
If you want to have services that can be worked on and deployed independently, then you need to avoid the quite nasty, often pathological coupling that comes from sharing the same database or reaching into somebody else's database. And so we talk with microservice architectures. Typically, if a microservices needs to store, manage, or mutate state, that it does so in a database that it owns, that it controls, and it hides from the outside world. So if we want to move from a monolithic system where our data is probably one big database to microservices, we've got to pull that database apart. This tends to be where a lot of these migrations falter. So people can find ways to pull the code apart, but they don't bother to pull the database apart, and they leave themselves without really getting the benefits from that microservice migration. Okay, well, if we want to break the database apart, that's difficult, right? I mean, these relational databases, they're often relational databases. A lot of their power comes from being in one place, right? They're amazing things, databases, and we're going to have to do some horrible things to a relational database in order to get that data out. Things like breaking from key relationships and messing up join queries and potentially having to give up on transactional integrity in some areas. So I really wanted to give people a whole load of patterns and different techniques in that space to show what is possible. But again, also to show that you shouldn't have to make this change daunting. You're not saying we're going to do it all today. We're going to say we're going to make one step today, and that step will get us further down the line of where we want to be. So trying to show patterns that, again, like the application things, are kind of refactorings. There's small changes you can make to a database that allow you to edge yourself into the right direction.
Yeah, I love that phrase, pathological coupling. That's a great phrase. One of the techniques you talk about in there was change data capture, which is one of the ones I think is fantastic for being kind of incrementally moving towards more of an event type of driven system. Can you talk a bit about change data capture and how you might leverage that technique in decomposing a monolithic database?
A lot of the patterns in the book are patterns that pre-exist the microservices world, and I've just tried to take those patterns and show how they can be used in the context of microservices. Strangler pattern is one example of that. The change data capture, really straightforward idea. It's basically once a change is made in one data source, you can capture that change and pass that change on somewhere else. And a lot of CDC systems basically work by looking at transaction log of databases. Large numbers of people now, this is one of the biggest use cases for Kafka, right? You use something like Debezium. It looks at the transaction log of your database. When a bit of data gets inserted, and if event gets pumped out over Kafka. Things can then subscribe to those events, can be used for data replication, and it's a classic part of normal ETL processes. So change data capture could be really useful if you need to replicate state between two different systems, potentially because you're looking at something like a transitionary mode where you've got maybe two sources of truth for a period of time. I have a couple of patterns in there I share about things like the example from Square and the tracer write type situation, although they didn't do CDC there. But it also can just be very useful in terms of attaching behavior on changes in the monolithic system. So I think I give the example, what happens if I want to award points when an order is placed. The only way I know an order is being placed is when an order arrives in the database. Well, when an order arrives in the database, I could have it fire an event via a change data capture pipeline, maybe over Kafka. I could then receive the event that says the order has been placed, and my little loyalty microservice could then start adding and awarding points to you in exchange for your order. So it can be really nice system, actually. I think the one challenge with any change data capture system is it requires that your CDC pipeline knows about the schema. But at this point, you're normally talking about a monolithic database, which is so difficult to change that no one is changing it. So it often is quite stable. But there are some good modern tool change in that space. I don't think it's just narrowly looked at in the world of ETL anymore. And I think there was a really good case study recently from Airbnb talking about how they did CDC as part of their microservice transition. I think they built their own internal system for that.
Yeah, Debezium with Kafka that you mentioned, those are two that I'm familiar with. They're pretty powerful in that space. So we're nearing the end here, and I wanted to touch on just a few growing pains. We've talked about a handful of services, but I want to kind of talk about as you continue to scale some of the challenges that people face. So I want to talk a bit about frameworks, things like service meshes, and maybe just touch briefly on kind of things like logging before we wrap up. So there's a quote that you have in the book, more services, more pain. As you continue to scale out your services, are frameworks just a foregone conclusion, things like service meshes?
Not necessarily foregone conclusions. I think service meshes are a great example. Service mesh is a conceptually simple idea, but the quality of the implementations in that space are still variable. So I have been giving people the same advice about service meshes for the last 3.5 years, which is if you can wait 6 months to work out which service mesh you pick, wait 6 months. And I'm still giving that advice, right? So I think conceptually they're good. I mean, the whole point of a service mesh is that you get to push a bunch of common behavior into the platform. The difference between maybe that and, say, a normal framework like Spring Boot is that there you're relying on the framework running inside the service itself. So maintaining consistent behavior across a whole bunch of services is difficult because you can't say, right, everybody upgrade to Spring Boot version 15 or whatever, because you don't want to be doing those kinds of deployments. With the service mesh, you can have some degree of common behavior running in the platform. The thing is, of course, service meshes, they really are only primarily for synchronous communication. They don't really give you many solutions or any help at all, really, in the world of, say, async communication. And just look at the variety of different options you've got around them right now. I mean, Istio just realized the other day we need to completely re-architect it and rebuild the whole kind of architecture of how Istio is built and run and managed. So I love the idea. I think something like that might make sense as part of your future. But I think what's more likely to be what we're looking at is not you've got to run on Kubernetes and on a service mesh. It's more likely going to be something like most development in the sort of next 5 to 10 years will be done on some kind of fast type platform. And I think that's much more likely going to be the future for most developers, even if under the hood, it's a giant hellish Jenga stack of Kubernetes and Istio and Knative or something else.
What advice do you give on the observability front, talking about logs, metrics, and tracing? As you deploy more and more services and get more and more scale, those logs continue to get bigger and bigger and bigger. How do you deal with just the volume of logs and metrics?
I think volume-wise, okay, there's some balancing forces here because on the one hand, you don't know what you need until you need to ask the question of the data, right? So one level, you want to lean towards logging as much as you can. To be honest with you, logging and log volumes, if you're logging a lot of data, you need to quantify what a lot of data is and look at the capabilities of the log aggregation platform you're looking at. Something like Elk Stack, for example, the Elasticsearch, Logstash, Kibana, the thing that's most concerning there in terms of large volumes is Elasticsearch. I spoke to a big SaaS-based company. They had a dedicated team just running Elasticsearch just for their Elk Stack cluster. But they're dealing with quite large volumes. A lot of people aren't actually in that space. But if you are at the massive volume space where you're generating so many logs, then there are dedicated log aggregation tools that are great at doing that to pay some money, right? But get Humio and you'll be happy. I think it's a bit different with logs versus other types of data and metrics and things like that, because often when it comes to things like large volumes of data, if you can collect that information in a semi-asynchronous or batch-oriented fashion, which is how most log aggregation is done, that allows you to sidestep a bunch of the problems. But there are other situations where you need to collect data in such a way that you need the data to come through now. Distributed tracing is a great example of that. You need a single wall clock to do effective timing to look at how long something takes. So you look at systems like Jaeger, Honeycomb, or Lightstep, and those are kind of quite different bits of data you're gathering there typically, because the logs, they just need to get to me within the next kind of couple of minutes. But when I'm sending traces as part of a distributed trace, they have to come through in a synchronous fashion. Because of the large volumes of data that you often deal with there, you don't want to affect the running system, which is why you would use sampling. To be honest with you, it's very hard to say this is what you're going to need. Again, it comes back to this idea of the dial, right? So I always come back to the key points. You need to get the data off of those machines and stored somewhere centrally where you can actually go and ask questions of that data. So that's the first thing. So you need to get your logs out, you need to get your metrics out, and you need to stick them somewhere where you can query them. Ideally, these are queries that are structured queries that are repeatable, structured and repeatable queries. The tools I tend to look at for metrics and certainly for tracing, if I've got no money, I'm looking at maybe you doing a mix of Jaeger and Prometheus. If I've got money, I'm looking at Lightstep and Honeycomb, just because they are tools that have been built with these systems in mind. I think the biggest challenge is they look quite alien to some people.
Recently, we've seen some projects, some companies, some different architectures that have been kind of reverting, going from microservices back to a monolith, at least like a process monolith. Istio-D comes to mind. Why do you think that is?
Oh, it's really straightforward. They didn't read my books. One of the things I've talked about a number of times is the challenges of microservice-related architectures being operated by the end customer, right? So when you create a piece of software that you're giving to somebody to have them own and manage it, that's an issue. With a microservice architecture, you push a lot of complexity into the operational space. All of that complexity is visible to the customer. So you've now got to run effectively a little mini microservice stack, which was the original Istio architecture, in order to run your microservices stack. So actually, by moving it all back into being a single monolithic process, they make the operation of that much simpler. I think if people can't see the inherent irony in this, I don't know what to do. But that's why they've done it, right? And actually, I think it's good and it's healthy. The fact it's taken so long for them to do this is a bit of a worry, especially given that Istio is effectively the underpinning of what is now going to be Knative. Although, now it's in Google's only hands, who knows whatever's going to happen there. So it was totally understandable. I'm glad they did it. I think it was the right thing to do. I think it was a brave decision. I don't read anything into it about Istio not being fit for purpose, but just, again, this is a fairly fundamental change that has come 2 years since they sort of stabilized what Istio was supposed to be. So I think this is why I say the space of service meshes is still not stabilized.
I think it was pretty brave, though. You got eat your own dog food, so you want to build on top of the patterns that you're espousing, but they also understood that customers were fighting with the complexity of what was there. So I think it made a lot of sense. Very, very brave.
Totally agreed.
So last question, what's next?
Back to writing and lots of remote consulting and remote training for my clients, and hoping my internet holds up. That's basically my next life for the next, I think, 6 months.
I hear you, Sam. Well, Sam, thank you so much for joining us on the InfoQ Podcast. As always, it's great to chat with you.
Thanks so much, Wes.